So this chapter of your part 2 actually carries almost 7 marks. This and the next chapter both carry 7 to 8 marks, which are the maximum marks among all the chapters. If you see other chapters, 5 marks, 6 marks तक के questions आते हैं, but these two chapters, that is organic chemistry, some basic principles and technique, and the next chapter, that is hydrocarbon, both together almost it is 16, 14 to 16 marks के questions आते हैं आपके 11th standard में. Okay, so from that itself you can understand how important this chapter, both chapters are. Plus, these two chapters are important for you because in 12th standard you will be studying part 2, which will be totally organic chemistry. So if you don't study these two chapters well, you will be not able to understand part 2 of your 12th standard. That is why I told you that you should go through the content. We will be going fast. Though in 12th standard, yes, we will have revision short about the content when we'll start the topic, but then you have to study these chapters in 11th standard itself very well. So we will be again going fast only because the initial part of this chapter is almost same. We have already done it, okay? So I hope you people have read the chapter. If you have not read the chapter, you will read it today after I finish the topic so that you understand it more better. Okay, so you are all able to see the PPT now. It is organic chemistry, some basic principles and technique. Now, how did it all started? Okay, so this Wooler, one person who was very much interested in forming ammonium cyanide chemical reaction. He wanted to prepare ammonium cyanide, and this is how he believed that this compound can be prepared. Okay, but while after carrying out the chemical reaction, he found that some compound was formed, and that compound had formula or had composition, that is NH1 nitrogen, nitrogen, hydrogen, oxygen, carbon and nitrogen. That is two nitrogens, four hydrogens, one carbon and one oxygen. But it did not have any properties of ammonium cyanide. And then he realized that something else has been formed, and he understood that it is nothing but urea. Urea is an organic compound. At that time, it was not possible to synthesize urea. It was believed to be present only in urine of humans and animals. So while doing this chemical experiment, instead of preparing ammonium cyanide, that is this compound, urea was prepared by mistake. And that time, uh, the carbon oxygen bond compound came into existence. It was believed earlier that organic compounds cannot be synthesized. That is why the name organic has come naturally from the nature. They are organic by nature. But then, after the formation of urea, many organic compounds could be prepared in laboratory, and a lot of preparation we are doing now. So, what are these organic compounds? Compounds that contain carbon and oxygen, or carbon and hydrogen. Okay, compounds that contain carbon, oxygen, carbon, hydrogen, with few other atoms such as oxygen, nitrogen, and sulfur. So, all hydrocarbons, simplest organic compound which consists of carbon and hydrogen atoms. So here we are going to study about organic compounds, particularly hydrocarbons. Okay, in this chapter, methane, which is that should be capital here. Okay, is the simplest organic compound we know. So organic compounds are composed of carbon. So why carbon? Why carbon is so special? We already again know this. 10th में हमने पढ़ा. Just now in P block also we studied about carbon. Carbon is unique. It is special because of tetravalency, catenation, and multiple bond. So what is this tetravalency? Carbon with 4 hydrogens around it. This tetravalency. Who has come late? अथर्व. Okay, so if you see carbon, it is tetravalent. See the structure. Just 1 minute. Okay, are you able to see the screen now?
Yes, ma'am.
Okay. So here we see carbon is tetravalent. That means central atom is sp3 hybridized and four groups attached to it. What does it mean? It means that carbon can form a bonding which is very stable. Okay. So tetravalency having tendency to form four covalent bond is one of the special properties of carbon that we have already seen in the last class. You have already seen in one of the chapters of your 11th standard. Next property is catenation. Catenation property of forming long chain by self-linking with itself. Carbon can form bond with itself, sigma bonds, and those bonds are very, very strong. They can form long chain, ring, double bonds, uh, and that behavior is called as catenation, and that is also one of the special properties of carbon. This catenation is also shown by silicon, but to a very, very lesser extent. Even silicon is tetravalent, but again to a very, very lesser extent. And multiple bonding. This is again a special property of carbon which is not found in any other compound. Double bond. Why so late? People want to join the class 8:30. Okay. So if you see this multiple bonding, carbon can form multiple bonds with itself and many other compound like oxygen. Okay, it can involve in double bonding with oxygen. One example is CO2. If you see carbon with double bond oxygen, my question will be, I have already discussed in the last class. Carbon can form multiple bond with nitrogen, C triple bond N. Carbon is involved in triple bonding with itself and with nitrogen. See, I've taken few examples, carbon, nitrogen. So why carbon is able to form bond with oxygen or with nitrogen? Why not with some other elements? Why carbon, nitrogen kind of compound? Carbon is able to form multiple bonds with itself and with other elements. Can anyone give me the answer? Yes, no one has answered. Carbon is forming multiple bonds with itself. Are you able to listen? Carbon is able to form multiple bonds with itself and elements like oxygen, nitrogen. Why is it so? Why not it is able to form multiple bond, let us say, with elements like sulfur or phosphorus?
Covalency.
If you remember, we had discussed in P block elements that carbon is small in size. Why carbon is able to form multiple bonds? See, why carbon is able to show catenation? The reason is small size. If you see oxygen's position in the periodic table, it is also just close to carbon in the second period. Or if you see nitrogen, they are all present just one behind the other in the periodic table, and the size goes on decreasing. Small size is the main reason why carbon is able to show a lot of catenation. Why carbon is able to form multiple bonding. If you see between carbon and oxygen, multiple bonding means there's a pi bond here. To form pi bond, to p, no, p y and p z orbital should be very close to each other. That is why they will be able to overlap with each other. If the bond length, sigma bond length is large, if this bond length is large, then they will not be able to overlap effectively. So to form multiple bond, that is to form pi bond, the structure should be small. The sigma bond should be small. It should be small enough that the atom should come close to each other and pi bonding is possible. Okay. So is the point clear? Is the
Yes,
point
ma'am.
clear? Why carbon is able to form multiple bonds? Yes. Are you able to listen? Getting my voice?
Yes, ma'am.
Did you understand why carbon is able to form multiple bonds?
Because
Because
it
of
has
small
small.
size. Because of small size. Yes. See, if you say think about a structure which is very big. So let us say one structure is here and another is here at this distance. Sigma bond इतना लंबा बन गया है. P lobes ऐसे रहते हैं. I'll show you one picture if you have not understood. So if you don't get the things very clearly, you should see this structure. So this is sigma bond, okay, and this is pi. So if this bond length is big, let us say दो phosphorus overlap कर रहे हैं, this bond length is very big. Then pi bonds का जो overlapping है, pi bonds have to bend and overlap. यहाँ पे और यहाँ पे देखिए, है ना? So this will not happen. अगर हुआ भी तो वो उतना strong नहीं होगा. Bonding उतना strong नहीं होगा. Carbon being small in size, it is very easy for the empty p orbitals or the p orbitals having electrons can overlap. The same thing is possible. Carbon से भी छोटा हो जाता है ऑक्सीजन या नाइट्रोजन के ना मल्टीपल बॉन्डिंग. फ्लोरीन के साथ ऐसा नहीं हो सकता है बिकॉज फ्लोरीन is smaller and highly electronegative. It just starts pulling the electrons of carbon towards itself very strongly. So best fitted one are nitrogen and oxygen are the best example. That is why carbon is the size of the carbon actually makes carbon so special. फिर आप जब आप बोलोगे ऑक्सीजन का तो और छोटा साइज है, नाइट्रोजन का तो और छोटा है, बट ऑक्सीजन नाइट्रोजन में इलेक्ट्रोनेगेटिविटी स्टार्ट्स डोमिनेटिंग. And that is why they're not able to show all the properties same as that of carbon. So small size, tetravalency, the electronegativity tendency is not very high in carbon. It has sharing tendency. That is why multiple bonding is very easily possible. Okay. Now, if you see the structure, see this all chapters you have already done in your first part, how carbon is being formed. But still, I wanted you people have to have a little idea. So I have added this part in the chapter. It is just one line given in your textbook, but the concept should be clear. So formation of methane. One of the example is methane. Methane's the carbon's electronic configuration is 1s2, 2s2, 2p2. Okay, so what happens when excitation takes place? Energy is available in the system. One of the electron from here goes to 2p. So now we have four unpaired electrons, one in S and other three in P. They will undergo hybridization. They will mix, rearrange themselves, and they will give a sp3 hybrid orbital of this kind. Lobes. They are all sp3 hybrids, each having one electron. This pink color structure, what you see. And then hydrogens will come and overlap with one electron to give us methane molecule. Okay, so this is how methane will be formed. Now, if you see this structure, carbon, ethene. Ethene again is formed of two carbons. Okay, but then it is not sp3 hybridized, it is sp2 hybridized. See, carbon can show variations depending upon what it is forming. So here again, if you see the electronic configuration, 1s2, 2s2, 2p2. On excitation, again you get 4 unpaired electron. But when methane is being formed, one of the electron will not participate in hybridization. It will remain unhybridized in 2pz, while the three electrons, one is in S and other two are in P, will undergo hybridization. So once this happens, you will get sp2 hybridization and unhybridized lobe. So this is your unhybridized 2p, this one. And from this, the sigma pi bond formation takes place. The electron cloud is above and below. So this is your sigma bond, and now the pi bond or a double bond has formed in ethene. So if you see formation of ethine, similarly, same thing will happen. Four unpaired electrons, but only two will participate in bond formation. The other two will remain unhybridized. The other two means this two. This two will remain unhybridized. See, sp hybridization, and these two are unhybridized. So this two, one is here, one is here, one electron here. Let us say 2p x, 2p z, and this is your 2py. So there is one pi bond here up and down, and another pi bond up and down. So there are two pi bonds now. One sigma bond, one pi, another pi. So again, carbon can After hybridization, you must have studied hybridization that depending upon the number of bonds needed, जितना bond चाहिए उतना ही hybridization होगा, बाकी सब unhybridized रह जाएगी. That is one of the postulates or assumptions of valence bond theory. So formation of methane, ethane, and ethyl. Are you clear with this?
Yes,
Yes. So this is what you have studied in chemical bonding and molecular structure. So I hope you have got a little idea how methane, ethane, and ethyne has been formed. If you have doubts, please ask. Okay, let us go further then. You don't have doubt. Percentage of S character. So if you see hybridization, S and P orbitals mix and recast to give new orbitals, and then we call them as sp3 hybridized, sp2 hybridized, or sp hybridized. So there's a term called as percentage of S characteristic. So if one S and three P orbitals are combining, the percentage of S character is found to be 25%, 75% P characters. If sp2 orbitals are combining, sp2 hybridization अगर होता है तो one S and two P's are combining. So sp characters में से percentage of S character is 33% and 66% is P characters, and SP में 50% S, 50% P. So we don't talk about P characters here, we talk about S characters here. Okay, so why we talk about S characters? More the S characters, stronger and the shorter is the bond. Okay, S characters का मतलब होता है, you know, S orbital are more closer to the nucleus. S orbitals are more closer to the nucleus. So more the S orbital, electrons in S orbital, stronger and shorter the bond. So you see this point, more S characters bond has, stronger and shorter the bond is. So if you have SP-SP bond, it will be strongest. Then if you have SP3 bond, it will be weakest. So why is it happening? So if you see the structure, this is a let us say this is carbon. So S orbital will be nearest. Then you will have P orbital away. So electrons present in S orbital will be most closest to the nucleus, and as a result, the bond will automatically become stronger. The bond will automatically become stronger. The bond is stronger, the bond will automatically be a shorter bond. So if you talk about sp3 bond, if there is one sp3 hybridized carbon and there's another sp3 hybridized carbon, the bond will be weakest among the three. So remember, more the S character, more stronger and more shorter will be the bond. So if you see, sp characters are more in S character, that is 50% S character is more in sp hybridized carbon, and that is this one, this bond. Okay, sp bond. That is why when these carbons, they will be more closer. This carbon and this carbon will come more closer, so overlapping becomes more easy. यहाँ पे, in this case and in this case, and hence it is possible. Okay. Uh, One more thing which you should know about S characters is, based on the S characters only you get the bond angles also. sp3 109, sp2 120, and sp is 180 bond angle. sp में 50% S characters, the more electrons are closer to the nucleus, and hence they start occupying maximum space, and hence the lobes are at the maximum distance. So more the S character, more is the bond angle. More the bond angle, more stable is the compound, let us say, more stable is the structure. So S characters also decides the bond angles also in the structure. S character and electronegativity, this is also one of the important point for a 12th standard, because there are various questions where electronegativity ke base pe questions aata hai, and the reason is S characters. Okay, as I told you, if the electron is in S orbital, it is more closer to the nucleus. If it is more closer to the nucleus is able to keep those electrons more or hold those electrons more tightly. And in other way, we can say that it becomes more electronegative. Electronegativity is nothing but the tendency to pull the electrons towards itself by the nucleus. So we can say that that particular atom, a particular element is more electronegative. So hybrid orbitals have more s having more s characters are more electronegative because s orbital is near to the nucleus and hence more attracted by the nucleus. Hence, attraction of electron in a bond towards nucleus decreases in the order sp, sp2, sp3. So if you see sp, if the electron is present in sp hybridized structure, it will be most electronegative, and if you have electron sp3 hybridized में होगा, it will be least. So if you have a structure, carbon structure, if you want to compare carbon in ethyne and carbon in ethane, the carbon in ethane will be more electronegative than carbon in ethane. Okay, so see, normally हम say the carbon is not very electronegative, but then it depends upon, now it will start depending upon what type of hybridization it has undergone. So if you have a structure where there is a carbon, a single structure where there is a carbon which is sp3 hybridized, a carbon which is sp hybridized, then sp hybridized carbon will be more electronegative and it will pull the shared pair of electron towards itself. Pi bond, कहीं पे भी ऐसा अगर स्ट्रक्चर आएगा तो कार्बन इलेक्ट्रॉन्स पुल करेगा. Okay, like suppose you have a structure like this, CH3 with a bond, then you have another structure where you have CH2. So if you see this structure, see this carbon and this carbon. This carbon is sp2 hybrid, this carbon is sp3 hybrid. So this carbon will be more electronegative. So इन दोनों के bonds में shared pair of electron किसके पास ज्यादा जाएगा? यहाँ पे ज्यादा जाएगा. It will be pulled by this carbon, and hence this there will be partial plus and partial minus charges developed here. Okay, you get this point? This is important point. I hope you have understood this. More the S characters, more electronegative that carbon will become, is a point. Okay, do you get it?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay, and you should remember SP. Normally समझ SP मतलब 50 S है 50 P है, तो इसमें सबसे ज्यादा है इस कैरेक्टर, इसमें कम है और ये उससे भी कम है. Okay, so you may have this type of give reasons. You may be given this structure and you may say, okay, this structure is the CH2 bond is more polar or CH3 CH2 bond is polar. Give reason for it. Okay, we are not looking at this slide because it's some additional point, not part of your syllabus. S characters and bond length. As I have already told you that more the S character, more stronger and more shorter is the bond. So this is also you need to remember. As the S characters increases, the hybrid orbitals come more closer to the nucleus. Therefore, the bonding electrons in sp hybrid orbital, the CH bond, that is in ethane, will be more closer to the nucleus compared to that of ethane. So CH bond of ethane will be more shorter, CC bond of ethane will be more shorter compared to that of ethane. Okay, so more the S character in the structure, more shorter and more stronger is the bond. More the S character in the structure, more electronegative is that element. This is what you need to remember from this particular point. I hope you have understood what is S character, because not at all explained in 12th standard. You should remember this. And textbook में भी उतना नहीं दिया, but then you can remember the points as एस कैरेक्टर में क्या आपको याद रखना है, यू हैव टू रिमेम्बर किसका कितना इस कैरेक्टर है. SP 50%, SP2 33.3% and SP3 में 25%. More the S character, more shorter the bond, more stronger the bond, and more electronegative the element. This is what you need to remember. Okay, then there's one more thing that you need to know, that pi bonds, if a structure has only sigma bond and if a structure has pi bond also, who is more reactive? So it is found that pi bonds provide the most reactive centers. That is, when you have a CC single bonded compound and you have a CC double bond and triple bonded compound, the double or triple bonded compounds will be more reactive. They will react more faster because pi bond will participate in the reaction. The sigma bond will not participate because sigma bond is more stronger than compared to CC single bonded compounds. So यहाँ पे क्या होता है, the electron charge cloud of pi bond is located above and below the plane. Pi electron cloud कहाँ होता है, ऊपर और नीचे की तरफ होता है, न्यूक्लियस को डायरेक्टली फेसिंग नहीं होता है. Sigma electron cloud is directly facing the nucleus. So as a result, these electrons are not very tightly held by the nucleus. They're towards the periphery, we can say. They're out towards the outer environment, we can say, and they're easily available for the attacking reagent. And hence we can say that if there's a pi bond present in the structure, that particular compound will be more reactive. So if you have ethene and ethane, will be more reactive by nature because of presence of pi electrons, while ethane will be not reactive because ethane में सिर्फ sigma bonds रहेंगे, pi bonds नहीं रहेंगे. Okay, so this is again one small point.
मैम,
हाँ बोलिए.
explain the previous slide again.
एक मिनट. हाँ हाँ बोलिए.
ये वाला slide
हाँ, इसमें क्या हुआ?
थोड़ा सा डाउट हो रहा है.
हाँ बताइए. बोलिए.
The electron charge cloud is located above and below the plane of bonding atoms. वो
About,
ऐसे
there is some line, the electron cloud of a pi bond is located above and below the plane of the bonding atoms. हाँ, ये पूछ रहे हो?
हाँ
ये this bond, actual bond is this bond. Okay, sigma bond. ठीक है, they are talking about this line means what? Above and below the plane of the bonding atom. This is one plane where you have sigma bond. sigma bond जब बनेगा, वो पहला बॉन्ड बनता है. वो बनने के बाद ही आपका पाई बॉन्ड्स बनते हैं. सो दिस इज एक्चुअल बॉन्ड, मेन बॉन्ड. So this line, the electron charge cloud of pi bond is located above and below the plane of the bonding atom. This is the plane of the bonding atoms. Okay, and this is above and below. So इस लाइन का एक्चुअल मीनिंग ये है कि ये जो इलेक्ट्रॉन है, ये दोनों इलेक्ट्रॉन, ये बॉन्डिंग इलेक्ट्रॉन बोले जा रहे हैं, which means that they are first forming the bond. Once this bond is formed, then the further bonding formation takes place, pi bond. Okay, and this electron cloud is above and below. We all know that electrons are not just located at one place. For our convenience, we use such kind of pictures. Okay, so there's an electron cloud. एक एरिया होगा इस दोनों कार्बन के चारों तरफ, जो ये पाई इलेक्ट्रॉन्स, सिग्मा इलेक्ट्रॉन्स ऑक्यूपाई करेंगे. दैट विल बी making them stable at their position. And then there will be some area above and below that area where this pi electrons will be occupying their positions. So that is why these two electrons are said to be bonding these two atoms. बॉन्ड बनने के बाद ये बॉन्डिंग इलेक्ट्रॉन्स है और ये दोनों बॉन्डिंग एटम्स है, कार्बन, ये कार्बन. सो ये प्लेन है. दिस लाइन we can consider as a plane of bonding atoms, and carbon are bonding atoms, and these two electrons are bonding electron in that situation. यही डाउट है या कुछ और है?
यही डाउट था.
ठीक है, क्लियर हो गया अभी?
हाँ.
Okay, so we understood now why pi bonded compounds are found to be more reactive than sigma bond. Remember, sigma bond break नहीं होता है. हाँ, जब भी multiple bonding होगा, sigma bonds नहीं break होते हैं, pi bonds ही break होते हैं. तो structure doesn't get affected much. Okay, now next part is structural representation of organic compound. How can we represent the structures? Here you need to practice again. There are different ways: complete structure, condensed structure, bond line structure. See, complete structure, where you represent each carbon with a double bond, with a single bond, hydrogen. आप सब properly represent करते हो. ठीक है? In this case, you are able to see this, or I should enlarge it. See. So here each carbon and each hydrogen bond is very clearly visible, expanded structure. No one gets confused. Here it is condensed, where I have CH3, some bonds I have CH3, CH3, where I have not shown actual bondings. Okay, few bonds I have shown, but all bonds I have not shown. And this is bond line, where you simply put lines. Here in this structures, the points represent carbon. All the points represents carbon. Okay, so if you put carbons everywhere, here hydrogens are not shown. Accordingly, you will satisfy the value. Like यहाँ पे one carbon है, but इसके चारों तरफ और कोई bond नहीं, एक ही bond है. तो यहाँ पे एक bond हो गया CC, बाकी three hydrogens रहेंगे. So we have to just assume कि यहाँ पे CH3 है, यहाँ पे CH3 है, यहाँ पे carbon है, one bond, two bond, three bond. तो यहाँ पे एक hydrogen होगा. तो यहाँ पे CH है. यहाँ पे if you see this carbon, one, two, and there is one more pi bond. So three bonds already happened. So CH double bond, CH है, CH3 है. This is called as bond line structures. Bond line structures where we actually don't represent the structure, but we simply use line. This is very helpful if you are doing a lot of synthesis. You don't have much time, so फटाफट lines बना दिए जाते हैं. So for that convenience, this structure has come into existence. Mostly we use this type of structures. This gives little idea about the bonding, and wherever not necessary we don't show bond, but initial stage pe this structure should be used. Once you are very much clear, then you should start using this structure, and then later on when you have become expert you can use this structure. CBSC, as far as 11th and 12th is concerned, CBSE prefers this structure in your exam. Okay, don't go for bond line structures in your board exams. They are not accepted. If you score if you score above 90, that is 70 means if you start scoring 60 above, you will be losing some marks because of bond line structures. Okay, so you should not use too much of bond line structures, particularly while showing synthesis or chemical reaction. You should use condensed structures. Bond line structures are not being used in 11th and 12th standard. Please remember, because आप classes जहाँ जाते हो, competitive exams की classes जहाँ जाते हो, वहाँ पे ज्यादा ये सिखाया जाता है. So please exam में आप avoid कीजिए using this structure. Try to use this structure. One more example I'm showing you about the structural representation. We already know Lewis structure, how we represent carbons. So this is an example of I've taken of propane, where we can represent structure in different forms. Lewis structure. So carbon with one electron and hydrogens giving electron. So complete structure where it is very clear carbon hydrogen bonds kahan present hai. This is a condensed structure where we are not showing any lines bondings. CH3, CH2, CH3, condensed structure. And this is a skeletal structure where you have just simply put a mountain kind of or a head kind of thing. This is CH3, this is CH2, this is again CH3. Okay, so these are different ways we can represent the structures. As I told you, if you are not very much comfortable, start using this structure, then you should go for condensed structures. And
Can you explain why have you written a skeletal form for line diagram of propane?
it is uh, it is what you're telling. It is also known as skeletal formulas. Skeletal, like in our body we have bones, no? We have bones, a human skeletal system. This is also just a base, interior of the structure, let us say. So it is in that format. Line form बोल सकते हैं, skeletal formula भी बोलते हैं. Like it looks like skeleton, ना? हड्डियों जैसा रहता है हमारे body में. Instead of drawing the whole structure, we just draw the skeletal system. That is how it is known as skeletal system. But
Which
our book,
exactly we have to use in a school examination?
you should use condensed formulas. You should start use condensed formulas. You should avoid using bond line structures. You should use condensed formulas. 11th में तो ठीक है, it is internal, no problem. But 12th you should use condensed formulas only. You can use this, but you should avoid using bond line structure. You should not use bond line structures in your board exams. Okay, you should avoid using it. Because what happens,
Okay.
I'll tell you the reason. Your papers जो correction के लिए जाते हैं, it is not fixed where it will go. It will go anywhere in the country. There are schools which are very remote places, so the teachers may not be very expert in checking the papers and all. They will depend only on the answer key, what is given in the answer key. answer key will give condensed formula. So if you do this kind of structures, they may give you wrong, they may give you cross, and you may lose so much of marks unnecessarily, which you will not even come to know. So CBSE has given instructions that condensed formula should be preferred, more easy to understand, because there are various remote places where you may not get teachers who are very much accustomed to this kind of, क्योंकि 11 12 तक होता ही नहीं है ना, इसलिए हायर क्लासेस में ही यूज किया जाता है. So then the teachers may get confused and you may unnecessarily lose marks. That is actually the reason why you should not use this. You should avoid using such things where you can lose marks without any reason. Okay. So that next is 3D representation. Again, we don't use much in our 11th and 12th standard 3D representation. This is necessary when we talk about stereochemistry, stereochemical concept. Use in higher classes only. Okay. So here, if you see, this two lines indicates in the plane, and this line indicates this on the paper. Okay, these two lines are on the paper. This edge which is coming towards us, it is out of the plane towards the other side, and this line indicates back side. Screen के पीछे जा रहा है. So actually 109 degrees का 3D structure होता है ये, where these two lines are on the plane of the paper. This is going behind, इसलिए dash 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 use किया है. Dotted lines भी use कर सकते हैं. And this is a thick line which is coming towards us. See the arrow, it is bigger here, the point is bigger this side, this is towards us, and this is going away, thick and becoming thinner, going away. So this is a 3D representation of methane. Again, we don't use much, only you may be asked in your exam, draw 3D representation of methane, that's all. Okay, so we will stop here. I hope you people have understood this part. I'll be doing classification tomorrow. Try to take some structures and try to draw their condensed formulas and this kind of structures. थोड़ा practice करिए आप बैठ घर पे, ठीक है? It will be better if you start practicing now. Because nomenclature में बहुत ज़्यादा time मैं spend नहीं करने वाली, इसलिए मैं आपको अभी से ही कह रही हूँ, ठीक है? So we will stop now and go and please read the chapter again. If you have any doubts, ask tomorrow. Thank you, everyone.
Thank you, ma'am.
Thank you.
Thank
Thank
you,
you.
ma'am.
Thank you,
Thank you,
ma'am.
ma'am.
Yeah, welcome everyone.